Okay, so let's kind of walk through this lab here. I believe I put it in the write-up. The instructions were intended for a higher level programming class than this, so some of the things mentioned there were kind of taken for granted that people knew how to program. Like I think one point in there it just says, well, use the flux to set up the pattern. So it was written for a higher class, but if you read through that, get some of the basic content, it should be good. Just kind of an introduction. The content's still good, and just kind of introduce these topics here. So since we can't be in a classroom, I found this site, Tinkercad.com. It's by Autodesk. So you might need to set up an account. Autodesk is free for students. I believe this one's free anyway, but Autodesk stuff is always free for students, so just set up an account with your Ivy Tech email, and then go ahead and sign in. And as I put in the write-up, if anybody lives near me, I did buy a dozen little kits to work through this lab, so if you want to meet up and borrow one of those and then work with real components to the virtual one, just let me know. But the virtual one, it will work to kind of introduce the topic, get you started, and if you want to play around with it and learn some more about the stuff, it's a whole lot cheaper than buying a bunch of pieces. So once you set up your account and sign in, you should be looking at a screen something like this. You want to go to this one here. It says Circuits. Go to Circuits, and I'm going to open this. Just to move to the other screen. I was a little worried I might get carried away because I really enjoy doing these things and have a whole lot of fun with it. And yeah, I was thinking I might get carried away, so I set up an example beforehand. But I wanted to go through the sign-in process on the video, so that was, I had to wait to open that. But I can refer to that little example and not get carried away. So I'm back here. We'll go to Circuits, and we want to create a new circuit. So there it goes. I always hate waiting for stuff to load on a video. So the basic idea here, I'll start it up here on the buttons. So this is rotate stuff. That's going to spin it. Once you bring your components in, that'll spin it around. Obviously trash cans are delete, undo and redo. Those are the main ones up there. Annotation means to make a note, make notes somewhere like little speech bubbles. Notes to yourself if you need them. And you can turn things on and off whether you're looking at them or not. That's those buttons. Then all this area here, this is your workspace. And over here on the side is the components that we can put into the workspace. So to start with, will be these two. Just click and drag over. And so this is Arduino Uno. This is a basic microcontroller. These are very popular. Near the end, I'll put a segment on just some reference material if you would like to carry this a little further. But this is the thing we'll be coding up to control everything. It's right in the name, microcontroller. So that's what we're going to program to control a bunch of little electronic things. Kind of what we would do to build a smart home. You know, have some little machine program to control everything in the home. So just getting started here, we're just going to look at some little lights and stuff. The other main component we'll need is going to be a breadboard. Just a small breadboard, that's this thing here. And let's see, I'll move these over here. Kind of get this set up. And so the breadboard is where we'll plug up our components, and the Arduino Uno is the device that we'll be programming. And in the real world, these just connect to the computer through a USB, and we have serial communication. So then we can do things like make custom controllers for software. That's what I find myself doing a lot, just for little hobbies and have a lot of fun with. I'll be messing with a piece of software and be like, oh, this isn't too bad, but this keyboard, I don't need the regular keyboard and mouse. So just give this a try. So I'll put together some little machine to make custom input for a software. I have a whole lot of fun doing that. But let's talk about what these, what's going on with the controller and the breadboard here. So I'll start with the breadboard here. Well, one nice thing about the virtual window is you can see the highlighting. So these are basically plugs. We'll just plug our components into these things and form connections to build a circuit. So you can see how down the side, these highlight all the way down. So these are connected. And that gives us a common ground rail. Because to form a circuit, things have to, the electricity has to start somewhere, come out, and then return to the source and form kind of a loop. So we always need a source and a ground to everything. And instead of running a whole bunch of pins over to a whole bunch of things to the grounds on the board, we can just have a common rail. That way all our components are somewhere near a source rail and a ground rail. You can see the plus and minus labels on them. And that's the same down both sides. And then these sections in the middle, these are where we form our connections. So you can see from the highlighting there, all 5 of these pins are connected. So we'll plug the component in to one spot and run it over somewhere else, and then come to a connected pin and run to another one, and we can form our connections that way. All those pins will be connected, so we just bring some electricity into one of these rows, then go through a component or a wire to another component or wire, from one row to another, and just connect things that way. So let me delete these little wires here. And that, so basically a breadboard is just a bunch of plugs, nicely organized and labeled so that we can plug things up and give it a try. Our microcontroller down here, so you can see the labels here. The numbers up here on this side represent our digital outputs or inputs. And basically, it's just a high-low voltage, a 1 or a 0. We tell the processor that, maybe this pin here, we want to apply a high voltage to that pin, or we want to take away the high voltage and have a low voltage. Basically, we either 1 to 0 or a 1 at that pin. We tell the processor that. Or we can read from them, and in that case, again, it's still just a high voltage or a low voltage. We ask the computer, do we have a high voltage or low voltage at that pin? And then we do something accordingly. And that's where we get our inputs and outputs. So that's the numbered ones here. You'll see some extra words here by 1 and 0. Those are more advanced things. Well, somebody's mentioned Bluetooth in the discussion board recently. The T and the R, that's transmit and receive. So you would need those for Bluetooth. These other ones down here, that's some more complicated things. And then there's a ground pin at the end. Down on this side, these A's, those are our analog inputs. So we can read analog signals. So instead of just the discrete values like a 1 or a 0, we have an entire range of values we can read. And these pins also work as digital output and inputs. So we can just write a high or low voltage to them, or read a high or low voltage if we just need more digital inputs. Then down here, some connections. The ones that will concern us here are the source voltages, either 5 volts or 3.3 volts. We'll use 5 volts for the lab here. And then a couple more ground pins. And that way we can form a circuit. So we'll have the 5 voltage volts of electricity come out of this pin over to our breadboard. I'll go ahead and draw that line. So we click on that, bring the mouse up here, and click on where we want it to go. So I'll make this positive labeled rail the source rail. So now all of these will have 5 volts when we need it. And when I said high voltage, that's what the digital pins send. So the digital pins, if we say write that high, that sends 5 volts. If we say write it low, it sends 0. We'll call it 5 and 0, but it's not exact. It might not be exact, but let's just call them 5 volts and 0 volts because that's easy to say. So our 1 and our 0, it's not really a 0 and a 1, it's a 0 and a 5. And then we'll send the electricity from the 5 volts, and then we'll bring it back from the ground. So again, I just clicked on that pin, I'll come up here to the ground rail and click on that. So now, wherever we put components in our middle section here, they'll be somewhere near a ground rail. That way we don't have to run a whole bunch of wires back over here. So now the components. Oh, might as well change those colors too. See the little box popped up over here. So that's the ground rail. Ground is typically black. Then our hot line. The hot one's usually red. Kind of standard. Y'all may have encountered that somewhere before in our society. So now let's look at the components. Now all these things over here, these are the different components we can connect. Some resistors and LEDs, those are mentioned in the lab manual. I talked about some other things such as ultrasonic rangefinders, ultrasonic distance sensors, what they call it here. A photoresistor is mentioned in the lab manual. PIR, that's a movement sensor. And you can hook those up on the virtual one and just kind of move your mouse around. You'll have, when you run the simulation, you'll have a little virtual hand or something. You can trigger the movement or distance, and a flashlight to handle the photoresistor stuff. You can play around with that. I'm just going to do a simple, but again, that manual was wrote for a slightly higher level class where people have had more programming experience. So we'll just do a simple push button. LED and some resistors. We'll just look at these 3 here at the top. Potentiometers can be nice. That's a resistor that changes. At the end, I'll point you towards some references if you want to look into some more stuff. So we're just going to do a simple circuit here. Let's start with 1 LED and just make it flash. So we bring it over, and you'll notice in the picture here, one of those leads is longer than the other. If you need the labels, anode is longer than the cathode, and the anode goes towards the positive side, and the cathode goes towards the ground side. Or just remember, the shorter wire goes to ground, longer wire goes to the hot. So just bring that in here and stick it on here somewhere connected to a couple of rails. Then we can give it a name, change the color. Oh, yeah, I'll leave this one red, so I'll call it red LED. Just a name to refer to it. We don't necessarily need that name. So, as mentioned in the write-up, a diode controls the direction electricity flows, and doing so sends off photons of light. So if it has a clear casing, then it's a light-emitting diode. So I'm just going to run from, say, pin 3 over to supply the source voltage. So instead of bringing it 5 volts, because that would just always be on, I'm going to come from one of these digital pins. And that way we can set up a timer, right? It's like on for a quarter second, then off for a half second, and just flashes back and forth like that. I'm going to build this a little bit bigger in a moment, so I'm going to go ahead and make that a red wire to match it. But we'll just say write pin number 3 high, and it'll turn that LED on. But again, we have to form a circuit, so we have to bring that back to ground as well. So I'm going to click there and drag that back to this little ground rail that was set up. So now there's a full circuit. The voltage is applied, so current of electricity is going to flow over to our LED, emit some light, and then whatever electricity is left after it emits light is going to flow back to ground. And again, that's ground, so might as well make it a black. So now we need to set up the code for this. So we do that over here. The button up here at the top, code, start simulation. So we click on code, and there's different ways we can do it. For those who have had programming before, you can just go to text and type the code in. Just real quick, it's a C-based language, C++-based language, and there are two methods that it'll look for. Setup will run once, so that's your boot up instructions. Anything to do with boot up does there, and loop runs over and over and over again. If you want to know if you have had programming before and would like a little bit more on that, let me know. But not everybody in this class has, so let's just look at the blocks. Or a good way to learn it is once we kind of drag our little blocks around to build up a set of instructions, you can also click on blocks plus text and see what those blocks translate into. That can be helpful for learning it. But since not everybody's had programming, I'm just going to use the blocks for this example. I'm going to get rid of these. Delete that, delete that, delete, delete. Okay, so we have different things. So our inputs and outputs, some control functions, do math, set up variables, a few different things we can do. I'm going to try to keep this simple. So we just wanted to tell it to write pin 3 high and then wait a quarter second, a half second, something, and then write low. So that's our second block here, set pin. So we'll just drag that over to our code section and we'll plug that into pin 3. So we want to set pin number 3 to a high voltage, and then under control, we'll wait 1 second's a long time. So I don't know, 33, a third of a second. 333 milliseconds. So that high voltage will turn the LED on. We'll wait a third of a second, and then we'll come in and turn the LED off. So again, then set pin 3 to a low voltage. And then we'll wait again. I'll wait a little longer, 555 milliseconds. So about a half second. So it's going to come on, then go off. And then it'll just repeat through that over and over and over and over again. It'll come on, go off. And for those who've had programming experience, again, you can put some blocks together and kind of see how that goes. In the boot up instructions, we just tell it pin 3 is an output. And then we write pin 3 high, delay for so many milliseconds. Drag some blocks in there, you can look at that, or there's lots of examples online. I'll point towards some of those at the end of this video. But now with that in there, we can come in and hit up here and hit this start simulation button. So you can see it comes on and goes off. Goes high, waits, goes low, waits, then all that repeats over and over and over again. So that's just going to keep blinking that light forever. So we probably want to do something a little more. Let's start with putting more than one LED in there so we can get a slight pattern going, right? Do a red light, and then a green light, then a blue light for different lengths of time. So let's do that, and then we'll put in some sort of input control. So we can just hit stop simulation to stop that from running, and then click the code button to get this out of the way when we get back to the components. So bring in some more LEDs. Oh, real quick, in the lab manual when I wrote it up, I mentioned transistors and using these as switches. You don't necessarily have to worry about that here. I mostly wanted you to be aware of that, because all these components will, though you'll be using in the lab, will work fine with 5 volts. But we're introducing this for IoT reasons, and you're probably well aware that while 5 volts will power a small LED, 5 volts isn't going to power the lights in your house. 5 volts isn't going to power your coffee maker if you start setting up some programs for kitchen stuff, a smart kitchen sort of thing. So for that, you would need 5 volts will, however, always flip a switch. So for that, you would need the transistors like showed up in the manual. I just want you to be aware of that for scaling things up, but we can kind of skip over it for the lab here. So let's bring in a couple more LEDs. Once again, the longer wire goes to the hot side, and the shorter wire will go to ground. So just put that in there somewhere. And we already have a red one, so let's do a green one. And if you want to give it a name, when you go to export the files, that would show up in the circuit board, the schematics and stuff. But for what we're doing here, we don't necessarily have to worry about that. And then once again, we'll bring one of our digital pins over here. So I'll go with number 5. So click pin 5 and use that to supply a high voltage to the LED. Well, it's a green LED, so I'll just go with the green wire. That way it matches. And then to finish the circuit, we'll need to bring that back to ground. So from pin 5 to the LED, and notice I didn't go right to the edge of the wire, I went to that row on the breadboard. And then from the other connection on the LED, that row in the breadboard sends a wire back to the ground, and that forms a complete circuit. And that's a ground wire, so I'll make it black. And then we could add that to the code, or we can go ahead and put the circuit together, bring in a third LED. Let's go with blue this time. Standard RGB coloring, which when you're looking, you'll see there's an RGB LED, has more pins. That one we can control what color it is. Those can be nice to play around with. Again, I'll point you towards some references at the end if you want to take this a little further, but we're just kind of basic introduction for it here. So for this, let's bring pin 7. We'll use that to bring the source in. And I'm going to come to a different row here, just to accentuate the point that all 5 of those are connected. So all I have to do is bring the 5 volt, the high voltage to that row, and it'll go into the LED. And then flow over to this other row, and then just any of these things, I'll bring it back to any of these in the ground rail. Change that wire to black, and click on this, and let's make that blue, that way the wires match. With 3 things, it's not so big a deal, but if you start messing around with this, if you kind of like it and play around with a little, some of your circuits are going to get bigger and bigger, and at that point it is important to color code the wires so you can keep track of what's what. Have some sort of color coding scheme going on. So that gives us 3 lights. So let's add that to our code. So our pin 3, that's our red LED, and we could set that to a variable if you wanted to. We can skip all that. We'll just use pin numbers for this, keep it simple. So our red LED goes high, and we wait for a third of a second, and it goes low. So then when it goes low, let's grab this set pin one again. After that, the green one turns off, red one turns off. We'll turn on the green one, so we'll set pin 5 to high voltage. Wait 555 milliseconds, and then we'll set pin 5 to a low voltage. So red light on, then wait, red light goes off. Green light comes on, we wait, green light goes off. Well, when that goes off, we'll want to turn on the blue light, which is over here in pin number 7. So we'll set pin 7 to a high voltage. And once again, wait for some amount of time. Oh, seems to be a pattern, 333, 555, and 700. 77 milliseconds. We're going to make sure you're in milliseconds, not seconds. And then we'll turn that back off. So back over to the output blocks. Set pin 7 to a low voltage. So red light's on, then off. Green light's on, then off. Then blue light's on, then off. And then that's just going to repeat over and over again. So let's run that. And it's something better. That's a little more than just one light flashing. So you want to see if you can get something together like that. And the next step I guess we can add some sort of input. Let's just add a push button input to this. So go ahead and stop the simulation. So to add some sort of control component in here, let's just use a little basic push button. Basically, this one will set it up so that it's high while we're pushing it, like while we're clicking on it, it'll be on, and when we let go, it's off. That's a fairly straightforward one, and that way we can set up some sort of condition. So we'll just bring that in. Notice it has 4 pins. So we have 1 A and B, and then we have 2 A and B. So you'll drag it in and put like the A and B here where they're into different rows on one side, the A's on one side and the B's on the other. And hook this up. Well, we never know when the button's going to push, so we don't want to set that on a timer. So this is one of those situations where we will bring in just constantly 5 volts feeding into that button. So somewhere in this rail, we'll bring in 5 volts. I'll make that red to indicate it's hot. That's going to be a hot wire. And then we need a resistor for this little setup. So I'm going to bring a resistor. Notice it's going back to ground. So the one right next to it. So here I plugged it down. The hot rail goes to the A side. So the other pin on the A side needs to have some sort of resistor going back to ground. And set that for 10,000. Oh, wait. 10 kilo ohms, which is 10,000 ohms, because kilos metric, the metric system, kilo means 1,000. So set that for 10 kilo ohms. And on the same side as the source, bring that back through a 10 kilo ohm resistor to ground. And now we need a way to read whether that button's being pressed or not. So on the B side of the pins here, the one across from the resistor. So the resistor, we'll see, is plugged into terminal 1A. So on terminal 1B, we want to bring a wire back over here somewhere. I'll just use pin 9. That'll work. And that's going to be a control wire, so I'll make that yellow. So there's constantly 5 volts being supplied to this. So that way whenever we push the button, that 5 volts can flow through. So normally that 5 volts just comes in here. It can't get across the button because the circuit is open, the switch is off, and can't get across the button, so it just flows through this resistor to dissipate some of the voltage and goes back to ground. The term for that's going to be a pull-up resistor. It's there because the voltage can't do anything in the circuit, so it comes back to ground, but we don't want the full voltage coming back to ground, so that resistor a pull-up resistor just burns up some of that voltage, is what that resistor is for. And then when we are pushing the button, well, then that 5 volts can flow through here, and it'll come back this wire, and we'll be able to detect it on pin 9. So let's go over and set up the code for that. So we will only want this to happen when that button's being pressed. So for those who've had the SDEV 120 class and gone over basic logic, you're probably familiar with if statements. So we'll grab this little if block thing and kind of wrap all of that. For those who haven't had that yet, the if blocks, you can think of that as a yes or no question. So instead, it says if, but think of that as is. So we're asking, is some condition that we're going to set up in a moment true? And if that condition is true, then do all this stuff. And if it's false, we'll just skip all this stuff. So it says if, but think of, for getting started, think of it as is. We're like, what is the thing we're going to put right here? Like, is this true? If so, then we'll do this. If it's not true, then we'll do something. Then we'll just skip all this. So it's like we're asking a yes or no question. And what we want to know is this pin 9 a high voltage? If it is, then we do this stuff. So to set that up, well, we need a comparison, which is a math thing, our logical operator. So here we have our arithmetic operators, add, subtract, multiply, all of those. And here we have our our comparison operators. Less than or equal, equal to, that's the one we want there. So we'll drag over our comparison operator. And we want to know if pin 9, this yellow wire here, has a high voltage to it. So that's going to be an input. And just like the output was set pin something, our input is going to be read pin something. So we're going to go over read digital pin, and it should kind of fall in that little hole. There it goes. So we're going to read digital pin 9, and if that is equal to a high voltage, which is one of our constants. So down here we have some constants for math, high and low, which you're probably familiar with here in computers, ones and zeros. 1 and 0 is just a quick and easy symbol to write. There's lots of ways we can say that. That means on or off. Well, really it means high voltage or low voltage. Sometimes on or off are better statements, sometimes true or false. Sometimes yes and no are the best words to look there. So just some sort of binary state. That's our ones and zeros. So a 1 is high and a 0 is low. So we're making a binary comparison. If digital 9 is a 1, then do all this stuff. If digital 9 is a 0, then skip all this stuff. Is kind of the question we're asking. What is the voltage on pin 9? If it's a high voltage, do this. And that's how those work for those who haven't had the SDEV 120 class. So that just gives us a condition to see whether we're pushing the button or not. So if we start the simulation, you can see our lights are no longer flashing. But if I come over here and click on the button, now they start flashing. Our pattern picks up again. Because once that button's clicked, there's a high voltage. And when I let go of the button, they're no longer flashing. So try and see if you can get that circuit together. Go ahead and stop the simulation. And maybe mess around with some other stuff. Look at some of the other basic components, or if you go to all, there's a lot of sensors to play with. Distance sensors, motion sensors, keypads for inputting things, and different ones to hook up. Or here where I just changed that, where it says components, if you come down to these, there's some starter setups. If you come to the Arduino setup, you'll see, well, here's an Arduino and a breadboard already connected with those source and ground rails on both sides connected. a little blink one, a push button. That's kind of what we just set up here. And there's a bunch of examples that you can go through and look at the examples and see how those go together just to get started. And again, when you're in the code, for those who have had programming before, you can just pull up the text for it, blocks plus text, and look at what your code, look at how those blocks relate to the code. And if you haven't had programming yet, you can just drag the blocks around. The term for that is no code, low code, where we drag our mouse around and then the computer writes the code in the background. It's kind of nice because computers never make a typo. Those are no code, low code solutions. But there's all these examples on here, so you can pull those in and kind of look at what's going on with those examples too. And just mess around with that and see if you get, see what you think about it. I have a lot of fun with it. A whole lot more fun in the real world, where I'm actually putting wires in there and connecting all this stuff. I really enjoy it, and lots of people do, so there are lots of resources available to get started in this. So let's look at a couple of those real quick, and hopefully that'll be enough to get you started on the lab. Just something basic will be good for the lab. Put together a circuit, get a screenshot of it, write up a short report, lab report. You know, it doesn't have to be long. A couple sentences to say how it went. And then that will take the place of one of the discussion boards. And you can choose which discussion board you don't want to do for that. But let's look at some of the resources for those who enjoy this and might want to look into it a little bit more. Well, actually, this little thing I just pointed at is a resource. So let's go back to a new one. I think I have to go back to get to a new circuit. It's cloud software, so it saves automatically. I think most people are probably familiar with that by now. So if we go to create a new circuit, wait for it to load, then, oh, that's neat. A little tip for the thing I was just going to. Go to components, and down to Arduino, and then choose some of these to kind of look at what's going on. A servo. So a servo is a common component in robots. It's a thing that spins. It doesn't spin all the way around like a motor. The thing that kind of spins back and forth, so like the joint on a robotic arm. It doesn't need to go a full 360 degrees, right? Probably 90 degrees of movement's enough. So the servo just kind of spins back and forth for that. If we look at the code here, you can see it's a little more complicated than that example we just did. But again, for those who've had some programming before, you know, pull up the code and kind of see how all that goes together. Let's get that out of the way. If we run the simulation, you see these are just a resource to kind of get you started. That's just something that spins back and forth and set up conditions for, you know, joints in a robotic arm to reach out and grab something. Would be one use for that. But Arduino stuff is open source, so there's lots and lots of things online to help. Obviously, just getting started with Arduino is a good place to begin. Arduino.cc, that's going to be the official page. And you can probably tell that's an Italian sounding name. So Raspberry Pis are another one that are quite popular, and there are lots and lots of microcontrollers. Raspberry Pis are SoCs, that's kind of spelled out in the write-up. So that's our two options, SoCs and microcontrollers. A Raspberry Pi is an entire system, whereas an Arduino, that's for mocking up a prototype that we would send off to a circuit board factory in China, and then they'd send us, you know, back to the PCB to just load into something once we get everything figured out. Whereas a Raspberry Pi is for making it's an entire system. So when we use a Raspberry Pi in a project, we kind of burn up the Pi as to we're making the working model. But the point I was going to make is Arduino, you'll notice that's an Italian name, and there are lots of microprocessors to use, but it's kind of like other Italian products, right? Put Italian in front of some some other products you've heard of. Italian shoes, Italian cars. It tends to stand out, right? And Arduino is the same way. Italian electronics. Kind of nice ones. So they're not the cheapest ones, but there are cheap knockoffs from China. But all the stuff's on here, and look for Arduino.cc is the official page. Obviously, tons and tons of videos. Lots of getting started videos, little things like that, up to all sorts of levels. You'll kind of want to look around. HC05, that was on my mind. HC05. This one was on my mind. That's a Bluetooth module. So then you don't need that USB cable going back to your computer. You can just do it all with Bluetooth. But all sorts of reference material, you just want to go in there and search around for it, kind of get started. And then these might help make a good starting point if you're working through this. But if anybody has any questions about this, let me know. And again, I bought a dozen little kits to do this in the classroom. So if you're anywhere where we can meet up, somewhere close to, I live in Clarksville, so if you're somewhere close to that, let me know and I'll let you borrow one of the kits to kind of work with the real ones instead of the virtual ones. But it's a good place to start. And let me know if you have any questions.